Hello and welcome to Empowered Learning. This particular lesson is a lesson about factorials. So we're going to learn what a factorial is, we're going to learn how to use it, and then we're going to use factorials to be able to evaluate some simple expressions. So let's go ahead and get started. With factorials, we see that a factorial is nothing more than a special type of recursive sequence. In case you're not familiar with what a recursive sequence is, we need to first back up and talk about what a sequence is. A sequence is just a function that its domain is just the natural numbers. So you can only plug in x values like 1, 2, 3 into it. And so when you plug in 1, you get a corresponding y value out. If you plug in 2, you get a corresponding y value out. So that's what a sequence is. A recursive sequence is a sequence where you have predefined terms for like the first 1 or 2 terms, and then afterwards you have a pattern that commences for the remaining terms. And our factorial pretty much does that. So as we see here, we have 0 factorial is defined to be 1. We have 1 factorial that's defined to be 1. And then to get the remaining of these numbers here within the sequence for the factorial, what we do is we take whatever the natural number is that we want, and we keep on multiplying it by successive natural numbers in descending order until we get to 1. So as you see here for 2 factorial, we have 2 times 1 equals 2. And again, we stop at 1 because 1 is the smallest natural number. For 3 factorial, we have 3 times 2 times 1. And of course, when we multiply all that together, we get 6. And then for 4 factorial, it's just 4 times 3 times 2 times 1. And you see we get 24. Now, if we keep going higher and higher and higher in natural numbers, eventually we get to a point where we're going to use a natural number n, okay? And so this is another way that we write this out in a more abstract way. So whatever the number is that we choose times the natural number that's 1 smaller than that times the next natural number that's 1 smaller than that, and we keep on going till we get to 1. So in essence, that's basically what a factorial is. It's just a quick way to multiply, let's say, 5 times 4 times 3 times 2 times 1 if we were doing 5 factorial, okay? Now, as a basic fact coming from what we know a factorial is, we see that we can take our factorial and not write it all the way out to 1. We could stop it, let's say, at the first number after what n is, or the second number, or the third number, or so on and so forth. To give you a quick example of what that looks like, let's say we wanted to know what 10 factorial is. So we could alternatively write 10 factorial is 10 times 9 factorial. And we know that's the same as 10 factorial because 9 factorial is just 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? Now similarly, just like how we're saying here, we could write it down 2 natural numbers. So we could go from 10 times 9 times 8 factorial. And we can even go down one more, 10 times 9 times 8 times 7 factorial, okay? Now, you're probably wondering why we even need to do this. Well, when we go over here to these examples here, we'll see that this will help us to be able to condense down the number of calculations that we actually do, okay? So we're going to go ahead and get started with these examples and then show you how we actually do that. So for our first one here, we have 5 factorial. So 5 factorial we know is just 5 times 4 times 3 times 2 times 1. And of course, if we multiplied all those numbers out, we would end up getting 120, okay? So for the next one, 8 factorial. So we know 8 factorial is going to be 8 times 7 times what? That's right, 6 times 5 times 4 times 3 times 2 times 1, okay? And if we multiply all those numbers out, you'll see that you end up getting 40,320, okay? Now for the next one, we see we have 6 factorial divided by 6 minus 2 factorial. And so Here I have this written here because since the 6 minus 2 is in parentheses, we know we have to do this first. So we have 6 factorial divided by 4 factorial. Now here, instead of writing this out as 6 times 5 times 4 times 3 times 2 times 1, and 4 factorial is 4 times 3 times 2 times 1, we could write 6 factorial is just 6 times 5 times 4 factorial. And so we're doing that because we know that this 4 factorial is the same as that 4 factorial. And so these two 4 factorials end up reducing to 1. And now all we have left is 6 times 5. And of course, we know that that is 30. Okay? So again, we could have did this the long way, but since we have this basic fact here, we know that we can actually shorten up our calculations here. Now let's work on this last one. So we have 4 factorial times 9 factorial divided by 8 times 6 factorial. Now, our strategy is we want to see which factorial is larger in the numerator and denominator and then break that one down. So you see we have 4 factorial, that is smaller than 6 factorial. So we don't want to break this one down just yet. But here we have 9 factorial, and that's larger than 6 factorial. So we can take this 9 factorial and break it down until we get to the 6 factorial part. So in doing that, we'll keep our 4 factorial the same for now, and then we'll multiply that times 9 times 8 times 7 times 6 factorial. And then of course that's divided by 8 times 6 factorial. Now as you see here, we have a 6 factorial in the numerator and the denominator, so those numbers reduce to 1. And surprisingly, we also have a 8 in the denominator and 8 in the numerator. So that also reduces to 1. And so now what we have left is just 4 factorial times 9 times 7. And so much more simple to calculate than listing all these factorials out. So now we know from over here that 4 factorial is just 24. And of course 9 times 7 is 63. And when we multiply all that out, we end up getting 1,512 as our answer. And so this shows you how we interpret what a factorial is, how we compute it, and how we use it to evaluate expressions that have factorials in it.